All right, so here we go. Please remember this is being recorded. 11.2, part 1. All right, so when we're talking about 11.2, part 1, I will tell you that one of the things that you're going to want to start to do is draw the shape of the base. Okay, the shape of the base is your underlying, this is how you name it. Like this is how you name the shape. This is how you pick what formula you're using. Okay? Because a lot of the formulas use the area of the base. Well, if you don't know what the shape of the base is, you're not going to know what the area is. All right. Now, why does this get confusing? Because the shape of the base will be any shape other than a quadrilateral. That means it'll be any other shape other than a parallelogram. Any other shape. Unless all of the sides are parallelograms. Okay? So the shape will be any other shape than a parallelogram. Unless all of them are parallelogram. So some people are like, well, what do you mean, Fraser? Okay, well, take a cereal box. If you take a cereal box, we're talking about three-dimensional objects, okay? We call them figures. Remember, shapes are two-dimensionals and figures are three-dimensional. So we're looking at a three-dimensional figure. If you look at your book, notice all the sides are what? Rectangles. They're quadrilaterals. You look at a box, a cereal box, all the sides are rectangles. But if you look at any other shape, so let me give you some other shapes. Let's look at this one. What would the base on this one be? No. It's any other shape you see other than a rectangle, unless all of them are rectangles. So you pick any other shape you see other than a rectangle. It's a triangle, yes. So the base is a triangle. The base is not what it's sitting on. Okay? That's the common English term. We say base is what you said. No, that's not what it is. The bases are parallel and they're congruent. So notice these two are triangles. That's a triangular prism, right? Okay? Because all of these are prisms and cylinders. When I look at my cup, notice, what shape do you see other than the fact that it's dirty? You see a circle. Notice, this would be a cylinder because the base is a circle. That doesn't necessarily mean the top and the bottom have to be circles. It means everything there is other than a rectangle. Okay? So if it was a hexagon, it would be a hexagon base. Even if it's laying on its side. That's the problem. Many of you are going to see shapes and or figures and they're going to have them laying sideways. And you're going to think the base is the one that's laying on the ground. That's not what it is. The bases are the congruent pieces. Okay, there's two of them. Right. So first of all, understanding that you were wanting to draw the shape of the base. And that the shape of the base is any other shape other than a quadrilateral. Unless all of them are quadrilaterals. Okay. Second of all, you have to understand some terminology. Okay, so I'm going to draw a shape. Okay, and then I'm going to draw a figure from that shape. Okay, so that is a pentagonal prism. It's a pentagonal prism. Why is it a pentagonal prism? Because the base is a pentagon. Now, you're going to see it presented to you on many of the tests like this. It's still a pentagonal prism because the bases are pentagons. It's just laying on its side. That's how they try to throw you off. All right? So making sure you pay attention and understand what is a base. And then all of these are called lateral faces. Hopefully you know what the word lateral means. It means on its side, correct? Like these are your lats, okay, along the side of your body. All right, now the easiest way, I will tell people, because many people have a hard time drawing three-dimensional shapes, is to draw the two-dimensional shape, then draw another two-dimensional shape and connect them. So for example, draw a triangle, then come down here and draw the exact same triangle, then connect the lines. There you go, three-dimensional shape. So if it was a hexagon, you draw a hexagon, then you come down here and you draw the exact same hexagon, and then you connect their points. And what do the dotted lines mean? Hopefully you know they mean you cannot see them, meaning they're in the back of the shape. So these are all three-dimensional shapes. Now, one of the things I will tell you not to do is never draw the three-dimensional shape. You're wasting your time. There's not a point to it. You want to draw the shape of its base. You don't want to waste your time drawing the shape, because many of you can't draw. It's okay. You don't have to draw it. I'm showing you how you could draw it, but I'm not asking you to. You want to make sure you draw the shape of the base. Okay? Once you have the shape of the base, you can find the area of the base. You can find the perimeter of the base. You can find all sorts of stuff dealing with the base, and it won't confuse you. You draw the whole picture, you're going to be just as confused as when you started. All right, so let's look at this before we start doing the formula and understand what we're looking for. There's your lateral faces, the one on the sides. Your bases are up top. Notice there's two of them. And they will be located with the big B. This stands for base of the shape. Or excuse me, base of the figure. Base of the figure. Okay? There's a difference between big B and little b, so you got to pay attention to your capitals. A little b is the base of your shape. You know, like base times height? The little b stands for base of your shape. The big B stands for the area of your base. Okay, so you got to be really careful. They do have two different meanings. And of course, these are all called prisms. Now we're going to be dealing with prisms and pyramids. What's the difference between a prism and a pyramid? Prism has how many bases? 2. A prism has 1. All right? Okay, so the first formula we're going to deal with is lateral area. And lateral area is the perimeter of the base times the height of the figure. Now, this H is generic, meaning they put it in the picture, and there's a lot of different heights we're going to deal with. Now, I'm just going to list them, and this is going to be the confusing part, because as we go through it, you're going to hear the word height a bunch. They're not all the same, but you still are looking for the same mark. What mark on your picture shows you where the height is? Hopefully you know you're still looking for that, the right angle mark. That right angle mark will some way, shape, or form show you the height of a figure, or the height of a base, or the slant height. There's a whole bunch of them. They all have the word height in them, and they're all different. So you have the height of a shape. You have the height of a figure. Okay. You also have a slant height. Those are all different types of heights we'll be dealing with. All right. So we're going to go ahead and talk about the two formulas. One of them is lateral area, which is perimeter of the base times height, and surface area. Now, surface area is the lateral area plus 2 times the area of the base. So you're going to start to understand why I draw out the shape of the base first, because keeping your work organized in this section will make you much more successful than just trying to hippie skip around. And this formula is not given to you on the EOC, the lateral area. They actually put a formula in for it, and it's not always the same. So it's really important that you focus on that. That first part of surface area on your reference sheet is the lateral area. Like they give you the lateral area formula, they put it in there, but they don't tell you it's lateral area. They just have perimeter times h. They have pH. So on your reference sheet, it looks like this: pH plus 2b. And you're supposed to know that this first section is that. They are the same. They don't tell you. You're supposed to know it. So when we're doing our work, you're going to see, you're going to have your formulas written, but when you use the reference sheet, you're not going to see lateral area in it. You're going to be like, what's going on? Hopefully you understand that perimeter times the height of the figure is the same as lateral area. And on the reference sheet, they just put it here, but they don't tell you it's lateral area. All right, so let's look at the first got it. The first got it is this right here. Okay. As we look at the first got it, you see the shape. Okay. Hopefully you're looking at it in your book because I'm going to move it away. All right. You pause it on the video or whatever. And what is the shape of the base? So I tell you the first thing you want to do is draw the shape of the base. What was the shape of the base? Correct. It was a triangle. And the measurements they gave you were 5, 5, and 6. So here's my base. Now sometimes they might only give me 2 of the numbers. Sometimes they might only give me 1 of the numbers. They might make this a special right triangle. They might make this a a squared plus b squared equals c squared type of triangle. They might actually even make you find sine, cosine, and tangent of this triangle. All that work's not going away. They're just adding to it. Now we're not trying to find the area of the base here, but we could if we needed to. What would I add to my picture if I needed to find the area of the base? Hopefully you know I would add an altitude. Now they're not asking us to find the area of the base yet, but I'm saying all of these problems look the same. You have to know what you're looking for. And in this case, they want us to find the surface area. So will I need the area of the base? You're darn skippy. Why? Because the surface area formula would be this, and you write it down. Surface area equals perimeter times the height of the figure plus 2 times the area of the base. So I'm going to need the area of the base. If I needed just lateral area, would I need the area of the base? No, I would not. Lateral area would just be the perimeter, which I have. I could add up all those sides. That's perimeter of the base, times the height of the figure. Well, that's the only other number I didn't put on here. That would be 12. So now I start listing the things I have. Well, I have the perimeter. Perimeter is what in this case? Hopefully you know, you add them all up, 16. The height of the figure is the only number that wasn't on my original picture. My picture of my base. That's 12. Now I need the area of the base. The area of this base is 1/2 base times height. So now what do I need to add to my picture? Most of you have already gone ahead and done it. I'm going to have to add a right angle mark. And I need this measurement. Okay. So I have to find the area of that triangle. I know the area is 1/2 base times height. I know the base is what? 6. Okay? So I'm doing my formula and I go area equals 1/2, 6, and I just need the height. Well, how am I going to find that height? Well, when I bisected it, I should know, or when I wrote this out, this was an isosceles triangle. So that means when I draw that altitude, I have the number 3 on each side. So now I have 3 here, a 5 here, and I'm looking for this. I got 2 of the 3 sides of a right triangle. Hopefully you know this would be a squared plus 3 squared equals 5 squared. Now, I know in my lovely little head that this is a Pythagorean triple. That means I know that that number's 4. You may not. You might have to actually go through this. This is 9. This is 25. Then you minus 9 from 25, you get 16. So you get a squared equals 16. So when you square root it, you get this equals 4. So now I have my height. Okay, now remember, this is just the area of the base. The reason they say area of the base is because your base can change. It could be a triangle, it could be a trapezoid, it could be a circle, it could be a square, it could be anything. That's the part that changes. That's why the area of the base problem and chapter 10 was so important. Because if you can't find the area of a trapezoid or a regular hexagon or a pentagon, then when we move on to find volume and surface area, you can't do it either because you don't know how to do special right triangle work. All right. So here we are. I've listed the things I need. I've found my area of the base. Now I just plug it all in. So I put surface area is 16. This is 12 plus 2 times 6 times 4 divided by 2. Everybody knows that dividing by 2 and multiplying by half are the same. Okay. And this 2 is important because in a prism you have how many bases? 2, correct. You have 2 bases in a prism. You'll only have 1 base in a pyramid, like in Egypt, the pyramids. And then this is all calculator work. You just put it in your calculator, and you should come up with I'll wait while you're doing your calculator work. And yes, Miss Coppage, what would it be?
No, I was going to say, wouldn't it be 16 times 4?
16? No. Because we're dealing with the height of the shape. This is the height of the figure. This is why you got to be real careful. Because there's 3 or 4 different types of heights, and you got to keep them all separate. That's the hard part. That's why when we go over this, it's important that you're going over it as we go over it, because this height, notice 12 is the height of the figure. Now, why do I know this height and this height aren't the same? Because I only drew my shape. I drew the shape of the base. And when I look at the figure in the book, you'll see that this was the only number that's not on my base. That's the height of the shape. Even though it's laying on its side, it's the height. Okay? So again, trying to keep that work organized. That's the key. Knowing what everything is. Then plugging it in correctly. So 6 times 12 is 190 what? Plus, hopefully you know those 2's cancel out. This becomes 6 times 4, 24. And what is 92 plus 24? Yes, you're correct. 226. And in this case, it would be centimeters squared, because we're finding surface area. All right. Okay, so let's look at another one. We'll turn it over. And this time, the shape is going to be a hexagon, a regular hexagon. It's got it, number 2. It's a regular hexagon. Hey, there it is, number 2. So hopefully you know what is the shape I'm going to draw on my picture. It's going to be the hexagon. And then I'm going to have to draw some probably right triangle work, because we need to write down the formula for a hexagon. So here we go. Surface area. We know we're finding surface area. This has got it, number 2. Surface area is equal to, okay, and we know the problem. It's a lateral area, which is pH, plus 2 times the area of the base. Okay, so do I have the perimeter of my shape? Well, let's see. We're going to draw the hexagon first. Okay, and do they give us any measurements? Yes, they give us this one here, 6. So do I have the perimeter? Yes, I do. 6 times 6 is 36. So I have the perimeter. Do I have the height of the shape? Well, that would be any other number that's not on my picture. Because I just drew. So when I look back at the picture, yes, I do have the height. It is 12. Okay. So now I have the front part. I can find lateral area pretty easily. But I do not have the area of the base. What is the formula for the area of the base? 1/2 perimeter times apothem. Yes, you are 100% correct. Oh, God, I thought we were done with this. Nope. You are not done with it. We use it again. Now, you already found the perimeter. Notice, the perimeter of the base and the perimeter is the same. So I already have that. I am missing the apothem. That's this piece. Oh, Mr. Frazier, I'm going to be doing some mad right triangle work. Yes, I am. So I draw my triangle. Right? Because that's this imaginary triangle here that we're replicating. We do the 360 divided by 6, and you get 60 degrees. That's this here. Remember, that's what we're finding is that interior angle. Then I'm drawing my apothem. See, this is my, so I draw my apothem. What's the apothem do? It bisects, right. So this is 60, this is 30. These two sides are 3 and 3 now. Am I worried about the radius? Do I need the radius? No. I'm looking for the apothem, this piece right here. It's across from 60. So that means the apothem is equal to 3 square root of 3. Now, why is that? Because when I go up from the short side, from the short leg to the long leg, you multiply by the square root of 3. So 30, 60, 90. I've memorized that. If I needed the radius, I'd multiply by 2 and I'd get 6. But I don't need the radius. I need the apothem. So now, do I have everything that I need? I certainly do. So now I have to plug it all in. So I do 36 times 12 plus 2 times, then the area of the base. Oh, zoom this back out. Then the area of the base, which is the perimeter again, which I already have. So 1/2, 36. And then the apothem, 3 square root of 3. Yes, many of you can start to see that this work is a nightmare because it's everything you've learned in this book so far. Here's the apothem. This was all from chapter 10. This work was all from 10. The only thing we're doing is adding this piece to it. So as you can see, then all of this is just typed in the calculator. And literally, because you have those fancy calculators, you can type exactly this, and you'll get the right answer.
How do you know, like, to use that height instead, like, in the last one you used, like... I
did use that. What do you mean?
On the other one, the height was 12, and you used,
Because they were two different heights.
How do you know which height is, like, what shape?
Because this is the height of the shape. It's always the height of the shape. This H is always the height of the shape. If there's an H in this problem, it's in the base because you're using the area of the base formula. So it's going to be in this picture.
Okay.
So you're either looking for something from this picture, an apothem or height. This height is not in this picture. But the perimeter of the base is the same as the perimeter of the base. Both P's are going to be the same. All right. Okay, so let's look at, well, they give you some easy ones. I'm going to go ahead and do the checked lesson understanding problem, problem number 3, because what is the shape of that base? Anybody want to try and guess? It's a trapezoid, right? It's any other shape other than a rectangle. Okay, so here we know this one's a trapezoid. So I would be drawing a trapezoid. I would still be writing out, okay, surface area is equal to perimeter times height plus 2b. I am writing this out so I can keep my work organized. I would need the perimeter. Notice, I'm going to need all 4 of these sides now. So if I were to do right triangle work, I'm going to need the hypotenuse. I'm going to need both sides. I'm going to need both bases. Of course, I'm going to need both bases anyway, because in order for me to do the area of this base, it's 1/2 height times base 1 plus base 2. Okay? So the area of my base is changing. I have to make sure that I write it down. And this is what I was talking about. You have a height that would be for this shape. That's needed for this formula. But there's a height for the prism, and it wouldn't be in my picture. It would be on the original picture. So hopefully you understand why I draw out just the shape of the base, because once I put my numbers on the shape of the base, I know whatever number I didn't put on the shape of the base that's in the picture is the height of my figure. Okay? Now, they don't give me any measurements in that problem. And I'm going to go ahead and just add measurements. These are made up. So this is 2, 2, 5, and 10. Which means it's what kind of trapezoid? Yes, you're correct. It's an isosceles trapezoid. Okay. So, I have the perimeter. The perimeter would be what? 19. Good job, guys. And then the height of the figure. The height of the figure I have not given you. It's not in this picture. It would be in the original picture, and I'm just going to make one up. We'll just make it 12 again, okay? Because as you can see, it doesn't have any numbers on it, so we'll just make it 12. All right. Now, can I find the area of this base? Anybody? Your resounding answer should be no. Why? What's missing for me to find the area of this trapezoid? Hopefully you know you're missing the what mark? The right angle mark. Now this is an isosceles trapezoid, which you should know everything would get cut into equal pieces. Now, this is where most of you are going to be like, what is he doing? Well, I have to do right triangle work. I just know both those right triangles are going to be the what? Same. Okay, I've got to find the height. That means if this is 5, what's this down here going to be? Correct. And these are going to be equal pieces, right? So how much is left over? There's 5 left over, so each of these are 2.5. So that'd be 2.5. This is 2. Who wants to tell me how I find this? How am I going to do that? 2 sides of a right triangle? First of all, can that be true? When you look, why? Barry, I like how you shook your head right away. Why is it that those numbers don't even make sense? Right. 2.5 is bigger than the hypotenuse. Okay, so there's something wrong with this triangle already, simply because you cannot have one of the sides be bigger than the hypotenuse. Good check. But I'm just showing you the process in which you would do the work. I'm not expecting the work to make sense. Okay? So, in other words, I've made up these numbers, and the reason I made them up is because I was just trying to see if you can rationalize through the problem. Once I find this measurement, I would plug it in for this height, and then I'd do 5 plus 10 times h divided by 2, and put it all in that problem. So I'll go ahead and change this, and we'll make it 4. And if I make those 4, that means my perimeter is now right, guys, 23. Okay, so we went back and fixed it. Okay, so now I'll put this over here as 4. Now what can I do? A squared plus b squared equals c squared. So that'd be x squared plus 2.5 squared equals 4 squared. This is 16. X squared plus 25 squared is 625. So that's 6.25. I would subtract 6.25 from both sides. So I get 9.75 equals x squared. Yes, I'm a math genius. Can somebody tell me what the square root of 975 is? X would be what? Sweet. 5 square root of 39. So now I have the height I can use in this problem. So I write it all out with all the numbers put in. I have the base, or the perimeter, is now 23 times that 12. Notice, I keep these two separate because this height was on my original picture. It's not on here. This height is on this picture. That's what I was finding. So plus, and then 2 times the area of the base. So that's 1/2. The height is 5 square root of 39. Base 1 plus base 2. I'm just going to put 15. Hopefully you know I just added them in my head. And then parentheses. And then I just put this all in my calculator at one time. Now the key is making sure you punch it right into your calculator. But you only have to put it in one time. Oh, you did?
Yeah.
So what is it? Is it not 5 square root of 39?
Yeah, I just put it.
Oh.
My bad.
See, this is good, though. You want to know why?
Because I just gave an example.
Of what people make mistakes, yes.
3.12.
3.12. So I can go ahead and just put in 3.12. It's always good. It's one of the reasons I like sometimes doing a taught live lesson, because you catch your own mistakes. What you have to be careful of. It's never, do I know what I'm doing? It's how careful are you doing it? Yes, sir. I did add the bases. 10 and 5 is 15. I just didn't write down 10 plus 5. I just wrote 15. And you can see that any problem that has 1/2, when you go to do this, these will automatically cancel out. 2 and 1/2 always cancel out. So it ends up being 3.2 times 15 plus 23 times 12. And that's called surface area and lateral surface area. I'm letting you know the right triangle work you had to do before was not for naught, because you're still going to have to do it. That's why those people who don't do well in chapter 10 struggle immensely in chapter 11. And I say, go back and retake chapter 10's test. You'll do better in chapter 11. They truly believe the 2 chapters are independent. And, oh, well, I'll just do better in 11. Not so much. It gets hard. All right. I would go ahead then, please, if you would. You're going to do problems 1 through 10. And some of you are like, shoo. Other people will see 1 through 10. Oh, awesome. Only 10 problems. As you can see, each problem takes quite a bit of effort. All right? Thank you very much.